Hey guys, we want to continue on with your periodic table notes. So you should have those available as well as a periodic table so you can follow along with some of the trends that we're going to talk about today. So one of the first things we want to talk about is atomic radius. Atomic radius is defined as half the distance between the nuclei of identical atoms bonded together. So that should make sense. If you connect the nucleus of two atoms, half that distance will belong to one of the atoms and the other half of the distance will belong to the other. What's important to know is for each trend, you want to know what happens, but most importantly, you want to know why it happens. And atomic radius is kind of the one that sets it all up because it's different. Atomic radius decreases as you go across a period because of increasing nuclear charge. As you go across the periodic table, you are increasing atomic number, which means you are increasing the number of protons. The more protons there are, the greater they can attract electrons. And because of that, the radius gets smaller as we go across the periodic table. The radius will increase as we go down a group, basically because there are more energy levels. There's an increasing number of orbitals, so those electrons will get further and further and further away from the nucleus. So atomic radius will decrease as we go across, and it will increase as we go down. The next trend we're going to look at is ionization energy. And you guys know an ion is an atom or group of atoms that either has a positive or a negative charge. They have either gained electrons or they have lost electrons. So ionization is a process that results in the formation of an ion. Ionization energy is defined as the energy required to remove, we're trying to take one away, to remove one electron from a gaseous atom of an element. Well, think about the periodic table for a second. Okay, over there in the halogens, we have 7 valence electrons, and the atom's smaller because the protons are holding on to those electrons pretty tightly. So the trend that you should see and be able to explain is that ionization energy is going to increase across a period. The atomic radius is smaller, so the electrons are closer to the positive charge of the nucleus. Ionization energy is then going to decrease down a group. The atoms are bigger. The atoms have a larger radii. The electrons are farther away from the positive nucleus. And the electrons that are there already have what's called a shielding effect. So in a shielding effect, the outer electrons are blocked or shielded by the inner electrons. So it's a little bit easier to take one away. Metals have characteristic low ionization energy. They love to lose electrons and become positive. Nonmetals have characteristic high ionization energy. They like to gain electrons more than use them. And then noble gases have extremely high ionization energy. They don't want any electrons taken away from them at all. If you're trying to remove more than one electron, it's going to become even harder because ionization energy will increase for each successive electron because each electron removed experiences more pull from the protons in the nucleus. The greatest increase in ionization energy you're going to see if you're trying to remove an electron from a noble gas configuration because it's already stable. Looking at the size of ions, cations are positive ions. You get to be positive by losing electrons. So cations are going to be smaller than the corresponding atom. The protons outnumber the electrons, so there's more pull of the remaining electrons toward the nucleus. Less shielding of the electrons that are left, and the trend tends to decrease from left to right across a period. Anions have gained electrons. Anions are a negative ion, so they have gained electrons, so they tend to be larger than the corresponding atom. The electrons now outnumber the protons, so there's more pull away from the nucleus. Greater shielding from the electrons that are there, and the trend tends to decrease as well across the period. A group trend tends to increase downward within a group due to additional energy levels. A third trend we want to look at is electronegativity. So electronegativity is a measure of an atom in a chemical compound to attract electrons. So we had just finished saying that metals like to gain, or nonmetals like to gain electrons, and metals like to lose them. Elements that do not form compounds, the noble gases, are not even assigned an electronegativity because they're already stable. So trends are that the nonmetals have characteristically high electronegativity. Our most electronegative element is fluorine. It's the smallest and it's the most electronegative. Metals have characteristically low electronegativity, and it is the lowest at francium. So if you look at the periodic table, you see francium in the bottom left-hand corner. It's going to be our biggest and our least electronegative. So if fluorine is the highest, then across a period you can see that electronegativity generally increases. And if fluorine is our lowest, you can see that down a group, electronegativity generally decreases. So this concludes our lecture on periodic trends. So you can stop the video, scan the QR code and answer the questions, and then work on Chem Worksheet 6.4 and Chem Worksheet 6-5. As always, if you have any questions, just let me know. Thanks, guys.